Hello everyone, reporting today for Fun Robotics Network. I'm Alhas, and with me here is Team 11212 Clueless from California. They've been absolutely awesome this season, one of the most compact robots I've seen. They have a bunch of neat little features like a brake pad, super innovative hang mechanism, intake turret, all the works. I can't wait to jump into it on Behind the Bot. Alright guys, so first question is obviously the size. Very compact robot. I know you also tried to really pack things in last season too. Why go for it this year?
Yeah, sure. So we knew from the start of the season that we wanted to have a very fast robot, as we thought that the drivetrain would be our most limiting mechanism, and we wanted to be able to intake from far and far parts along the submersible. So we knew that having a small robot would allow us to be very maneuverable and lightweight. So we could get a lot more acceleration and top speed by having a very small and compact robot like this.
Yeah, and now jumping into the brake pad, I think that's super, awesome. We saw brake pads a lot 2 years ago, not so much last year, but looks like you guys made a comeback with them now. First, I'll just push the robot around, and then can you actuate the brake pad? Yeah, and we can see definitely a lot tougher. Walk me through the mechanism. We'll pivot it up and show it actuating.
Sure. So we have a high-tech servo that's located just under the intake, embedded into the drivetrain, and that has an overcenter linkage that basically overcenters and it pushes this pad into the ground. And once that's engaged, it prevents the robot from being able to be pushed around.
Mm-hmm. And at what point in the season did you guys add the brake pad? Was it like a Worlds only thing? Have you been using it all throughout? Walk me through that.
Yeah, so we added it just for the Worlds tournament. We actually added it the night before we flew to Houston.
Okay.
We noticed that at our regional tournament, when we had this intake with a claw, we were able to be pushed around really easily. And so in order to prevent us from being pushed around, we added that so that we would be able to intake as a very lightweight robot and still not get pushed and play defense on.
Yeah, awesome. And as far as using it in teleop, is it something your drivers actuate every time? Completely automatic? Walk us through the software.
Yeah, sure. So this is completely automated. So every time when I extend the intake, my drivetrain stops moving, the brake pad will automatically deploy. And every time I retract the intake, it will automatically go up. So as a driver, I don't feel any difference. And when my intake is extended and I move the joystick past a certain amount, the brake pad will once again retract automatically. So you don't feel any difference as a driver with or without the brake pad in terms of driving. But in terms of getting pushed, it makes a huge difference.
Awesome, yeah. Now, the next thing I want to talk about is your lift. It's, again, like the whole robot, very, very compact. One thing that I think is super neat is your guys' wiring. Walk me through your wiring solution here.
Yeah, sure. So for the vertical slides, we use a coil cable, and the reason for that is it's much more simple to wire. So you don't have to have wires in the back of the slide inserts. Have all that mess in the wiring. So it's very simple, very, very nice. It claps down nice and neat, and it doesn't get tangled on anything like a normal wire does.
Yeah, and I've heard teams have issues with the recoil or springing of the coiled cable itself, and it's adding extra downforce to their slides. How have you guys combated that?
Yeah, we combated that with the counter spring mechanism at the back. So you can see on our insert, we actually has two sides. So on this side is a normal extension string. On this side is our bungee cord for counter springing. So this is a very similar mechanism to last year. So basically, you have a counter spring strung just like an extension string, but on the back here, it actually loops around multiple times, eight times on the bottom. So it increases the length of the bungee cord to make the force of the extension more linear throughout the travel.
Yeah, and I've seen teams go back and forth a lot on string versus belt, or if you're running one string, two string, things like that. So I noticed you have the counter springing only on one side, but yeah, why only on one side? And then also talk about your stringing route.
Yeah, the reason that our counter spring is only on one side is that we just simply don't need it on both sides, and it adds a lot of friction to have it on both sides. So that's the reason why we have it only on one side. And in terms of the stringing, we have extension string on both sides and retraction string down the middle. And for the retraction string, one of the issues we found at regionals is that the retraction string will occasionally jump off the spool, which will cause like a big issue with the entire robot. So we added this guide right after regionals to prevent the string from coming off.
Okay, very neat. And talking about the deposit a little bit, I know it's changed a lot throughout the season. Why did you guys settle on this final claw-based design, arm-based design?
Sure, so we started the season with a horizontal extension mechanism, and we realized pretty quickly that design, while it worked well, it was pretty complex and it had a lot of degrees of freedom. When we decided to switch to this arm mechanism instead, we found it to be a lot more lightweight, and so we're able to actuate it a lot faster. And with our very fast drivetrain and very small drivetrain, we're able to still reach both sides of the we're able to reach both sides of the drivetrain to intake and deposit out both sides. So we get all of the benefits of that extra reach without the associated harms.
Yeah, absolutely. And one question now, seeing the transfer mechanism, I know a lot of teams prefer to transfer when kind of everything's in its home position, so you don't have to rely on a lot of software. I see you guys are transferring sort of at an intermediate position. You need to raise your slides. Have you had issues with consistency there, or how have you made sure that all of the claws are in the right place at the same time so you don't miss any samples?
Yeah, so this was just something that we had to do when we wanted to lengthen the arm, because we didn't really have time to repackage our entire lift mechanism and deposit. So when we changed to a long arm, we realized that we would have to transfer with like more weird geometry. However, it did work out pretty beneficially for us, because with our long intake arm and the deposit arm, we basically transfer over the edge of the robot. So even if we ever mistransfer for whatever reason and we drop the sample, it'll never fall into the robot. It'll always fall outside.
Yeah, that's super cool. Okay, now jumping into the hang. There's a lot going on there, so walk us through it slowly. We'll turn it around and yeah, walk us through the mechanism, and then we'll show it actuating and stuff.
Yeah, sure. So for the level 2 hang, it's a very simple servo actuated linear rail. So you have the bungee cord pulling it up with this bungee cord and the bearing right here, and you have the string pulling it down with a spool down here. And so it's a very simple mechanism. Everyone uses pretty much the same similar thing. And for the hook, we have a retract right here. So again, bungee cord down here, and then you have a screw as a pivot down here. And the reason for the pivot is that once we get past the level 2 and hit a level 3 bar, this will actually need to pivot back to clear the robot to rotate around.
Yeah, and now about the level 3 mechanism. Super cool. It's pretty much a PTO, but done very differently than other teams this season. So walk us through that.
Yeah, so we basically have two spools, one at the top and one at the bottom. And so we double the counterspring in here as a method of basically unspooling this as we lift. So it's all connected on this axle right here. And as you raise the lift, you'll notice that our spool here is unspooling the string. So we always have a pretty tight amount of string here as we lift it up. However, when we raise the lift all the way to its maximum extension and you try to pull on the string, you'll notice that you can't pull it anymore. And so at our very top, we're able to then rotate. We can then rotate the spool on the bottom and then engage this motor just for the very few seconds when we're hanging.
Yeah, and as far as RPMs and torques are concerned, what motor are you running there?
So for the main slides motor is 1150 RPM with a 1 to 1.5 gear ratio, and for the hang motor is 435 RPM with a 1 to 2 gear ratio through this bevel gear.
Yeah, I feel like teams tend to run 60 RPM or 100 RPM motors for their main lifting mechanism. How light is your robot so that you can have such a fast hang for level 3?
Our robot is 28.7 pounds. Before that, we were 25 pounds.
Okay.
It got a little bit heavier after some of the changes we made for Worlds.
Very cool. And last question about the hang: completely automated, or what automations and what teleop controls do you have in there?
So in terms of the hang, there's not much automation. It's just the driver 2 has a couple buttons and they press it and the slides retracts.
Awesome. Yeah. Clueless, thank you guys so much. Just year after year, absolutely incredible robots. This one is no exception. They had a great run here in Houston, and congratulations again on the Ochoa Inspire Award. That's huge. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 11212, Clueless.